Welcome to Chips and Tips. I'm Justin Gray, and I've got two guests with me here. This episode is going to be titled To Quote or Not to Quote. And it's going to be three guys who all believe we're not good at quoting parts, talking about how we struggle to quote parts in our shops. So with that, I'll just give a quick introduction to myself. I'm Justin Gray. I'm the CTO at Toolpath, and trying my best to build out a product that can help people quote better. This isn't meant to be an advertisement for Toolpath or anything, but both these guys are Toolpath customers, and so they do have access to Toolpath as we talk about quoting these parts today. And so, James, why don't you go ahead and tell us a little bit about who you are?
Oh man, you got to put me on the spot here. My name is James Dyer. I'm from Dial and Nameplate. We primarily do gauge faces, dials, nameplates, things of that nature, but we do have a full machine shop, and we're ISO AS. We do a lot of ITAR work, mainly aerospace and defense stuff.
And your shop is in?
Oh, we're in LA, Glendale to be specific.
Okay. And John, tell us a little bit about yourself.
I'm Jon Rabinowitz, owner-operator of the Shop Incorporated in Florida, New York, and I do shop, and it's welding, fabrication, CNC machining, line boring, more of a professional problem solver.
Very cool. Florida, New York, and the Shop Inc. is just like perfect.
Generic, yeah.
Yeah, it's awesome.
Yeah.
Nobody will ever find you ever.
They find me. You thought I was in PA, so.
I did think you were in PA, yeah. Like I said, when you grow up in Connecticut, everything that's not Connecticut is Pennsylvania.
I couldn't tell if that was a Connecticut sense of humor or are you being serious.
No, it was just a bad joke to cover for my mistake. Okay, how much of your guys' businesses is CNC machining?
For me, 30% or so, 20 to 30%.
Okay.
Yeah,
I would have to agree.
We're still starting small, but yeah, slowly or quickly growing.
Okay. John, you're about 30% too?
Over the course of a year, yeah. Although like sometimes it's, kind of bundled up week by week. It seems like I'm doing CNC machining, or I don't turn my machines on for a couple of weeks or months, depending on the projects I have.
But it sounds like both of you guys are looking to increase the percentage of CNC machining in your business.
Absolutely.
Okay.
Yeah, I would say so.
Yeah, that's definitely a bit of a unique perspective. There's a lot of owner-operator shops out there who just get started doing job shop work. So CNC machining is their whole business. But you guys come from a different background where it's adding that into an existing business. So I think that'll bring a pretty different perspective. It'll be a lot of fun to talk through. It also really highlights some unique challenges in quoting that you guys have because, CNC machining is only part of what you do. And so your quoting environment is much more varied.
Right.
How long have you guys been making chips on mills and lathes?
Before I started doing my own stuff, I would say like overall a decade, probably. Like 2013 is when I started.
Wow.
Most
what about you, John?
Experience is manual machining. I did have a very crude little Chinese CNC mill that I got in 2000. I bought in 2011, and it pretty much broke more end mills than it did actually make parts. So I bought my Herco in 2013, and sometimes it takes me like a couple of months just to figure out how to load a programmer to get it wired up kind of thing. But it's definitely been on like an exponential curve as far as, using it more and more, and then CNC lathes and stuff too.
Yeah, you just got a lathe from HGR in Cleveland, right?
Yeah, so I had an Akuma, I have an Akuma 762S, and I've learned to really kind of like or love the CNC lathe, and then I just got a subspindle live tool lathe from HDR. Thanks from Joe at Cobra Frame Building told me about that, and I'm pretty excited to get that going.
We have to take a detour for a minute, and I just have to understand like the emotional state of when you're bringing a machine home from HDR. Like, do you have any expectation that it's going to work whatsoever?
I figure that they have a 30-day return policy, and just the cost of rigging both ways and shipping both ways, it would have been better just to like part it out if it wasn't going to work. But it was a pretty good deal though, so I didn't want to pass it up. But I did drive out there to actually go visually like and look at it myself. Whereas the two other CNCs I have, I just bought sight unseen and kind of just took a gamble on those as well. I like to turn wrenches and I'm pretty mechanically inclined, so I just figured if it needed anything, I would just fix it, and I have on both my other machines too. So,
well, give us the rundown of all the machines you have in your shop.
So I have a 2004 Herco VM2. So it's a 40 by 18 by 18 VMC with 16 tools. And then I have the 98 Okuma Crown 762S, and then that 2005 Duzan Puma 240 MSP.
Okay, so 3 machines, right?
Yeah.
Okay.
Yeah, and the self-built CNC plasma. So I'm on my second one now. And 3D printers, fiber laser, that kind of stuff, that's CNC too, but I don't think that really counts for this. They don't really make chips, they make messes, you know?
What about you, James?
Well, I have I think it's 85 Moriseki SL1A, which I haven't done anything else besides turn it on. I know it turns on. I'm not a lathe guy. I have a 92 Haas VFO and a 22 Haas DM2, and then a 07 Datron M35.
The VFO, is that the bubble plastic one?
Yep. And it leaks everywhere if you use coolant.
Ah, okay. All right.
Yeah.
I saw one of those at HGR too.
Yeah, one of the Tupperware machines. Yeah.
Very cool. Well, just for reference, I have a Sile X7 2019, I think 2021, and a 2022 Brother Speedio S500. And the parts that we'll talk about today, I think we made both of them. No, we made one of them on the Brother and one of them on both of them were made on the Sile. That's right. Both of them were made on the Sile. So when we actually get to the parts a little later on, those are 2 parts that I derived from parts that I actually made. I made them both on the Sile before we got the Brother, actually. Okay. Now for the fun question, the ice-breaking starter question. We'll go with you first, James. What's the biggest quoting mistake you've ever made?
Oh, assuming things. A lot of my issues are currently with outside processing, lead times, pricing, trying to get stuff of that nature. So I've had to assume certain aspects of a part. And then when I get that order, I realize, oh crap, I gotta now expedite this. And that's one of my biggest things. Usually I'm pretty good about finding hidden features, internal square corners, or holes that you wouldn't think were there, but are actually there. I'm pretty decent about finding that, but not perfect.
Okay. What about you, John?
Not having the right tool on hand, or not taking into account the due date, considering my other workload.
That's a classic one. Letting the schedule get away from you.
It's like, I'm going to be home late several nights this week. All right, babe.
For me, it was, I have a very acute one. I've made tons and tons of mistakes. Honestly, I feel like almost every part I quoted, I made a mistake on. But there was one part, it was a Xometry job, and they wanted a full inspection report for every part. That was like, I think I had to make 50 of them. And I thought, oh, this won't be that bad. And the price that Xometry was offering was quite a bit higher, and I didn't think it through. So I accepted the job, and then I went back and looked at the print, and there were 45 dimensions bubbled on the print. None of them were super hard to measure. There were a couple that were a little tricky, but the problem was I had to go do that for every part. I spent 4 times as long measuring the parts as I spent programming and machining them. It was awful. And I think it took me a day and a half to do the entire batch of parts. And there was no way that I charged appropriately for that. So, I guess I'm sure almost everybody gets bit the first time they have to do a lot of inspection, but man, that one hurt quite a lot. Okay. What kind of features typically would trip you up when you're quoting, or like what are the features you like see and hate and just I don't want to make that?
I mean, right now, heatsink fins. I'm over it. I've been doing it for the last 2 months. Like a lot of internal square corners, like and long reach stuff. Like right now, I'm doing a lot of 1/4 inch, 3 inch length. I'm over that stuff.
They won't let you drill out those corners, huh?
They will, but I still have to come back and clean it up.
Okay.
So right now it's rough. I mean, I'll still quote it and I'll still run them. I'm just tired of it right now.
Do you ever go back to your customer and say like, hey, here's your quote, but also you have to make these changes before I'll make your part?
Yes. So the project that I'm working on right now, I did that to them. The first version I made for them last year, I learned a ton. And coming back to it this year, they redesigned everything and included a lot of features that, yes, you can make. Like I can machine it all day long. But during that first revision, I told myself, okay, like for these heatsink fins, I'm going to use a slitting saw instead of I think I was using a 330 seconds extended reach 3 flute. And that cycle time alone was 7 hours. And if I use this slitting saw, it'll drop me down to 45 minutes. And they sent me the new revised part. I looked at it, realized I can't use the slitting saw at all. So I go back to the customer and say, hey, if you remove these features so I can get a 5-inch diameter saw through these features, then I can make this part for $800 less per part. And yeah, they went back, they revised it, they fixed everything, and that's what we did.
What about you, John?
I would say like length times diameter ratio, whether it be drilling deep holes sometimes or, like a tight corner radius that's rather deep, and the learning woes of those.
You were saying, go ahead.
I was going to say, I don't have through spindle coolant on my machine, and I have pretty low coolant pressure on the Okuma. So I struggle with those things. I actually bought a 1,000 PSI through spindle coolant pump from Easton at Moria a while back that I want to try to hook up to the Okuma. So when I go to do longer or deeper drilled holes, I can get better chip evacuation. Because right now I have the tech, and it's not really ideal when Seiko or Goering or anyone just to slam it in at 12 times D, and it's just like not doing that. Well, I have, but it also ends with the bit in pieces too,
I've never done it, but I would like to at least once have an experience doing some deep drilling where you have to like start with a shorter drill and then put the drill in the hole and before you spin it up. But yeah, it doesn't look like a lot of fun. How many part numbers do you typically see in a single RFQ?
For me, it could go 1 to 40. I mean, I only deal with the machine shop side. So next door, it could be 50 to 100 different line items. But for me, I would say average 15 to 20.
That's a lot of parts on a single quote.
Yeah.
Do you use any software to help you sort of wrangle that and keep it all in order?
Yeah. So we have ERP system. We use JobBoss. And so before I move everything into Toolpath, I'll upload everything into JobBoss, get the estimate going, so I have some sort of standardization of how I'm doing things.
You ever missed a part when you sent the quote and just forgot to add one of the parts on?
Yep, I did one last month. And I made the part too, and then I texted the engineer. I'm like, hey, I realized I didn't put this in the RFQ. I know you guys need it. I'm sending it to ChemFilm. I already made it. If you need it, cool. If you don't, then it is what it is. And yeah, he ended up not needing it. He had another shop that mainly does sheet metal and fabrication stuff do it. But yeah, that was one I missed.
What about you, John?
Typically, I would say 1 to 5 parts is on average. I've had a couple of different assemblies where it's, 15 different part numbers, but typically it's just one to three parts, and you sometimes usually higher quantities, but yeah, nothing really crazy, especially not 40. That would probably be a no quote for me, just as far as getting a number out there.
When you're quoting an assembly, are you typically delivering a completed assembly or just the individual parts?
Typically, it's the entire assembly.
So how do you think about assembly time and all of that?
I factor that into my quote.
Charge by the hour or like?
I more or less, yeah. So I at least stemming from like the fabrication and the welding and stuff like that. Sometimes material handling or assembly is going to be like a lot of the job. So I'll typically try to think how long it'll take, and then over the years, at least with those things, kind of like come to learning a handicap. So then I'll try kind of multiply that into what I think it's going to be. Because I always think that I can work faster than I can, or things are going to go smoother than they can, and they never do. So as long as I try to be honest with myself the whole time, the handicap seems to kind of be pretty accurate. And then I think it also depends on how big or small the parts are too, because I remember like trying to take some work on. It's like, oh, this operation is not so bad. I'm drilling a hole, except that the part weighs a couple 100 pounds. And it's just like, that really changes one hole, you know? So, yeah, kind of.
I've never had a part I couldn't easily lift.
I just had some parts some AR 400 cutting edges that they were too big for the Herco. So I had them hanging out the side. But I also didn't want to just offset and weigh the table. So I actually made some rollers, and I have a little spider crane. So I had that holding and supporting the work outside of the Herco. So as it rolled, it would hit on the roller, but as it moved in Y, the wire rope from the spider crane would like oscillate a little bit. So it allowed it to kind of have like a couple different axes of freedom to be able to handle those parts. It was interesting.
Huh. Yeah, I've never put a lot of thought into like making parts that are bigger than my travels, or that are bigger than the enclosure.
It's interesting.
What about post-processing type stuff? Chem film, anodize, heat treat. How do you deal with that in a quote?
For me, it all depends. If it's like a large assembly, and it's not common, so like some parts I'll have like bead blast, chem film, anodize, silk screen, a lot of processes after the machining, then I'll go to my outside processors and I'll actually get an RFQ from them. But if it's one part that you just need chem filmed, I know what their minimum lot fees are in typical turnaround times and things of that nature. So I can quote that stuff significantly faster.
So if you have to do a big quote like that, how long does it take you to get an answer back to them?
It depends. If like I have one vendor, they mainly do our powder coating and electroless nickel. They'll take a week or two to get back to me. Where chem film, I'll get it back same day. Anodize, I would say roughly 1 to 3 days for your standard stuff.
So if I add that all up, it'll take you up to a week to get a quote back to somebody if it's a complex, lots of post-processing.
Yeah, typically about a week. If it's more simplistic, like there's parts that I've turned around in 10, 15 minutes.
Have you ever correlated like quote speed to win rate?
Not really. Typically, what I'm quoting, my customers are already going to order it from me anyways.
Okay.
I help them with a lot of the engineering aspect, and granted, I don't charge for that. It's more of like a value added thing. So by the time I give them the quote, they already have a PO signed by their management, and they're just waiting to put a number on it. So I haven't ran into that issue yet.
What about you, John? A lot of your stuff includes like fabrication and extra non-machining work, right? So how do you think about quoting and adding all that in, and how long does it take you to get a quote back to somebody?
As far as for coatings, sometimes I'll deal with hot dip galvanized. If there's a high run of parts, I typically try and persuade the customer into powder coating, knowing that there's going to be less of a chance of having to rework the parts because my powder coater is reliable. I'm kind of weary about anodizing depending on the cost of the part, just because I've heard crazy horror stories. But depending on what the part is, I kind of know my anodizer's minimum lot charge. If it's just clear coat, if it's like a color that they'll have a high run in, so I know that their tanks are clean. If it's a oddball color, I won't quote it until I get a quote from my anodizer. And I'm usually also very particular on how I spell out, like, it must be, no blemishes. And if it is, it's like, depending on tolerance of the part, it starts getting kind of worrisome for me, just because I almost have to factor in, like, there is going to be a scrap part. So then, that kind of gets rolled into the price. If I have to do a lot of welding or something like that afterwards, or has to get sent out for like vibratory polishing or linear polishing or something like that, for a food customer, I won't just shoot off the hip with that. I usually have to, and a lot of times too, I have to go on site and measure what the part needs to be. So there's a lot on the line as far as me making the correct model and stuff like that. But then at least I have that information built to, get to those places for a quote. And I've luckily never had a problem as far as post finishing where it was going to be higher than what they did quote. Like, their quotes they'll stand by them. But I usually, if I have to do something that's that complex, there's enough padding on it that I'm trying not to race to the bottom, kind of race to the top a little bit on that. I'd rather not get the job and not lose money than get a job to risk barely breaking even, if that makes sense.
Yeah, you were telling me that you win about 70% of your quotes?
Yeah, 60 to 70%. And I used to get, like I was telling you, I used to be able to try and get every single job that came across the table. I don't know if it's because I felt like I had to, prove it to the customer or not let anyone else do the work. And a customer of mine actually had told me to raise my prices because they weren't where they should be. So I raised my prices, and they were actually confused why their prices went up. And I'm like, well, I'm going to raise it for like one verse. I'm going to raise it for everyone. I don't try to, within reason, I try and charge respectively to the customer, but I'm not going to charge you different than James. It just depends on if it's an industrial customer and how critical it is to their operation, where that's going to, tend to be a more expensive a part just because of opportunity costs and things like that, than if I just find interest in a job and I want to take it on because it seems like it would be a cool challenge, or I'm helping someone out more or less. Helping out within reason, of course, but
I don't know. I'm a pretty pain in the ass customer. I think you should probably charge me more than you charge James. Have you ever added a I don't want to do this for you fee to a job?
There's times when I feel like I charge for who I have to deal with and over what the job is in itself. So yeah, definitely. Or how long it takes to get paid from a customer, their price will go up substantially as well.
Right. Jamie from JSpec Engineering at IMTS had a funny shirt that said like my hourly rate, and I don't remember the exact numbers, but it was like $150 an hour for me to do the work, $200 an hour for me to do the work with you giving me advice, $300 an hour for you to do the work while you watch, $1,000 an hour for you to do the work while I tell you how to do it.
It's funny. I came from working on cars and a couple of different shops where it's like $100 an hour. It's $125 if I have to talk to you while I'm working on it, and it's $150 if you want to help while I'm working on it. Like that kind of thing.
Yeah. But how much if I bring you the parts for you to put on my car?
I can get it better online. It's like, great, but also no warranty. What do you mean? It's just like, you're supplying the parts.
Well, that's like customer supplied material. It's kind of a blessing and a curse, right? Like, you supplied the material, so it's not my problem, but also you didn't give me any extra, or the material's bent, or it's, not good quality material, or it's got weird saw cuts on it.
I close all that out. I just kind of put it on their lap. And it's like, you can do that, but if this, and this, it's like you're signing off on, that's the part that you're going to get and you're paying for it.
Have you ever done a job with customer supplied material, James?
I do quite a bit, but it's usually prefabricated parts like enclosures and things of that nature where I'm just modifying a off the shelf product. But otherwise, if it's like raw material like bar stock or plate or something like that, no, I won't touch it.
What about like really high dollar material? The worst I ever did was this big giant block of Peak that was $2,000. I paid $2,000 for the Peak from McMaster because they wanted it quickly, and I didn't follow the general rule that your quote should be never less than 3 times the material cost. I think that's a really good rule. So I quoted. I think I quoted like $3,000 for this part. The machining was, I swear, there was like 15 minutes of machining in it. There was nothing, and there were no tolerances on it. But it was a $2,000 piece of material, and I was so stressed out with that material on the mill. Like, do not screw this up. Do not make it too thin. You will lose. Like, if you have to buy one more piece of material, you lose your shirt. And customer supplied material is kind of always the same. Like, sometimes customers are nice and they'll give you like a few extra pieces or something, but you can't afford to have like 4 pieces of scrap, right? So,
so a lot of the repair work that I do is I can't afford to replace it, or depending on what it is, the company that I'm doing the work for can't afford the downtime. So a lot of times with the repair work that I do, it's similar to that, where it's just like you only have one opportunity. And that's a lot of why I like to work alone, is I can't afford that trust then to an employee. Like it's bad enough if I make mistakes, which I do. But luckily with welding and stuff like that, like at least with thread repair, you have a couple tries if you need to, depending on what it is. But, if the material is going to warp or pull, and, you kind of have to fight that as well. So a lot of times it's just, I'd rather take a lot longer than I need to not make a mistake. Doesn't, it's not 100% success rate, but
I think sometimes customers don't realize that, and it would do everybody in the industry a favor to like make it clear. Like, if you can give me extra on this part, like if you need 5, but you can give me 10, I'll actually charge you less, right? Like the pace at which I can work, my cost to reward, reward ratio is so much better. Hopefully you don't have a 50% yield on a part, but it happens. Especially if you're dealing with like thin wall stuff, or things are warping, or you have work holding challenges. I think customers don't always appreciate that. And then also I've heard stories, I've never had this happen, of like somebody will make 2 or 3 scrap parts because they don't meet the print. And then they hand them, they hand into the customer and they're like, hey, I made a few extra. These are scrap, but you can use them for like setup parts or whatever for yourself. The customer's like, oh, these are totally fine. I didn't care about that dimension at all. Right? Like, what do you mean you didn't care about that dimension? That was the one that made this part expensive. So that like DFM loop, I think, oh man, and in this industry, it's really tough, especially when you're dealing with like a larger customer, because they'll send the same RFQ out to like 10 shops. And it's, you either win it or you don't. And so their process of like getting that feedback back to the engineer can be really broken.
Getting material quoted sometimes is like, are you bidding on this job? I'm like, yeah, I am. They're like, oh, so and so. Happy if you're friendly with a material salesman, sometimes you can get inside knowledge on stuff like that. Or at least I have like a couple of times, but I don't feel like I really bid against a lot of people though, fortunately. So
that's interesting. The closest I've ever come to that was I was talking to AJ one time back when I was making parts, and I realized that we were both considering the same Xometry job. He ended up taking that job though, because he had the copper on the shelf to make it. And I was like, I can't even afford to buy the copper for the price they're offering on that. So
it seems like Xometry is more like, if you have the scrap laying around, sometimes that's where you're going to actually make the profit than if you have to buy the material too.
Yeah. There's a lot of that for sure. And I guess good for them for sort of turning that into a market, but it's not an easy way to, make a good margin on a part for sure.
Remnant machining.
Yeah. Yeah. The worst anodizing mistake I ever had, and I think our anodizers are pretty good, but it was the first time I ever brought them apart, and the first time I'd ever had anything anodized, and I'd only made one, which was a mistake. And I gave them the part, and they called and they were like, "This was supposed to be black, right?" And I was like, "Yeah." They're like, "Will your customer accept pink?" I'm like, "No, definitely not." And they're like, "Okay, we think we can strip it and re-dye it. You may have some dimensional variance, though." Luckily, it was pretty wide open, and the part was still in spec. But I didn't know that at the time, and so I quickly made another part and drove it down to the anodizer and said, "Here, you're going to do this one for free too, and I'm going to have two of them." So, yeah, that was interesting. I didn't even know that they could strip the die and redo it. But yeah, that was not a fun phone call.
I did handrails that were supposed to be clear coated, or they were clear coated, and I didn't realize, I guess some of my aluminum filler was mismatched inside of the tube. So most of the welds were fine, and some of them on 4043 were black on the welds. So,
Oh no,
not great. Yeah. And it was for high school, so I had to like redo one handrail section, but it wasn't so bad. Fortunately, it wasn't one that had like pickets or anything like that in it. So it was just a wall mounted railing, but yeah, it was a lesson learned, and everything stays separated now in my filler rods.
Interesting. Well, that brings us to a good discussion on tooling. How do you think about charging for tooling when you quote? Like, you've got your like standard tooling you always have in shop, tools last forever in aluminum. What do you do about like if you have to order custom tools for a job? How do you show that to the customer? How do you think about tooling?
I mean, for me, I'll just figure out what I need. And if it's anything specialty, like custom ground tools, things like that, I lump that into a quote, into a non-recurring prep charge. So that's how I do it. But for the most part, if it's aluminum and common tools, I'll just buy them if I need them. And then I have them on hand.
So it's just baked into your shop rate, essentially.
Pretty much, yeah. Unless it's like an astronomically expensive tool, like I have a 1-inch 3 flute end mill that was $500 from Helical. I made the customer pay for that one.
As an NRE, though, a non-recurring expense.
Exactly. Yeah. So it's like a one-time prep charge, just like how I would do fixturing and things like that. I just bake it into that one fee. And if I break it, it's on me. But with aluminum, chances are it's going to last forever.
Do you do mostly aluminum or all other kinds of materials?
I can do a lot. It's just what my customers want right now is typically copper, brass, aluminum. I've been doing a decent amount of 17.4. Was it 13.3? I think a little bit of that. Some plastics, but it's not super common.
Plastics are interesting because you'd think tool life would be infinite, but especially like acrylic, if you have a dull end mill, it does not cut nice.
No, you got to be sharp.
Yeah. 17.4, you definitely have to pay attention to tool life too. So do you raise your shop rate if you're cutting 17.4?
No. I mean,
no.
Well, because I'm quoting in Toolpath, so it'll tell me what the time is going to be. So for me, it's just whatever the time is going to take to make the part is what
interesting
I'll charge.
Interesting. We definitely, when we did quotes, not for Xometry, we would definitely charge a different shop rate for steels than for aluminums. Yes, the part will take longer to machine, but an hour of machining is still an hour of machining, and an hour of machining with steel tools means you're buying some new tools at the end of it. So we baked some like extra tooling cost into that rate. I think we would charge like 150 for aluminum and 200 for steel. But we made those numbers up. There's no science behind them. So what about you, John? How do you deal with like tooling cost in a job?
If it's something that I've come across before where I've needed it, I'll kind of take that as a more of a shop investment kind of thing. And I might roll some of the percentage into a quote, but if it's a custom tool or if it's like long diameter drills that I need specific for a job, I'm just honest with the customer. I'll show them what it costs. I don't try to mark that up, and I'll say, like you're going to buy 2 of them. And if I break any of them, it's all on me. So, some jobs I have an extra bit. Sometimes I have to buy a few extra bits and overnight them just so I can kind of meet a deadline. But as far as, like materials and stuff like that too, I do the first job I ever cut on my Herco was a 1/2-inch wide, 1.5 inch deep slot in 304. And so like a lot of because of my food customer, I deal a lot with 304, 316. And then as far as for turning, I do a lot of 304, 316, 17.4, Delrin and stuff like that. And then with more of my instant machinist friends, a lot of that is aluminum based, which is pretty nice because that's like cheating. It feels like it's like
everybody's a hero in aluminum. Yeah.
I don't really do any turning work in aluminum. And if I do, it's usually only like some manual stuff, but it seems like all the CNC stuff I do is usually stainless steel or 4140, whether it just be deep hole drilling or, large mining part kind of things. But yeah, it's all like all over the place. So that stuff's kind of interesting to quote.
I don't know why you made me think of this, but I have a small manual lathe in my garage. CNC lathes scare the crap out of me. But for some reason, I'll sort of happily stand in front of my manual lathe with absolutely no protection whatsoever.
Manual machining is kind of therapeutic, I feel like, especially on a lathe at least. Whereas I remember the first time I had my Kitagawa 10-inch chuck ramp up on the Kuma, I was just like, oh my God. It's like all the inertia happening inside this thing right now. Like where the glass is like, don't stand in front of this window. I'm like, I want to hit the button and like run away sometimes, but like kind of get used to it and get used to like, safer work holding or things like that. But yeah, it's interesting. I always try and get like the most aggressive hard jaws I can, depending on how big the part is and how big the stick out is and things like that. But
I've, on my lathe, I only have, like a 3-jaw spiral chuck. I've never gotten a 4-jaw or anything. I've never had a need for it, for the little stuff I do with it. But I've always wanted to play with one of those hand wheel 5C collet chuck things, like so the old style ones.
Yeah, the speed closers or speed.
Yeah.
Yeah. I have a 3J, a 5C, a 4-jaw scroll, a 3-jaw scroll, and a 4-jaw independent on my 15-inch. And it's nice being able to have the variety. I remember when I first started like getting into machining, I would like come across collets. I'm like, why would anyone want collets? There's like, you need so many of them. And like, the more I did work, I'm like, oh my God, if I can use a collet right now, it would make my life so much easier. So I got an entire set of 5C. I got a lot of 3J, and then actually Nub Tools, he makes a 5C 3-jaw conversion. But because of the limited capacity, I kind of just like reverse engineered his, and I made a 3J 3-jaw collet chuck setup for my Kitagawa. And that actually has been a lifesaver because you can, kind of bar pull up to 1 3/4 without having to cut soft jaws. And you also get hex and square collets. So it's really work holding, really efficient as far as swap over and stuff like that.
Work holding is an interesting topic in terms of quoting. When I first started out, I tried to do everything without making soft jaws. Like I hated making soft jaws. I didn't have a good workflow for it. And, for me, the cost of the soft jaw felt like waste in the system that I was trying to avoid. And so I would end up with the jankiest, sketchiest work holding, like holding on to like 30 thou of the part on parallels because that's how I could get it to fit or whatever. And it just never really occurred to me how much time I was wasting in scrapping parts until finally I was like, this sucks. I'm just going to make soft jaws. And so what I found was that like I started basically just putting soft jaws into like building it into the price of the part that I was making. So like if it's op 1, whatever, right. Mighty Bite or whatever they're called, Talon grip jaws or whatever, serrated jaws. And then op 2, 3, 4, like soft jaws, all the things, even if it's a perfectly square part, I just make soft jaws for it. And I found that was a much more reliable workflow for me. And so then the question became like, how much could I standardize this? Can I make a set of soft jaws cost like $15? I think we actually did get it down to be about that cost because we would build soft jaws and you could use both sides of them. So it was like $30 a pair, but you could flip them around and use both sides of them.
Dude, I cut like 15 different part numbers into one set of soft jaws if I can.
So, I mean, that's interesting, right? Because like I was trying to do the same thing. And then again, I was like, no, actually my time is more expensive. So like digging through the bin to find a pair of soft jaws I can use was like way more wasted time than just scrapping them after I turn them around. I mean, sometimes I would use them 3 or 4 times. But even then, if you're like facing it down to get rid of geometry or whatever, then you don't know how high the soft jaw is anymore. And so I do a lot of stuff off 0-point work holding. And so I found just like a more reliable, more stable process let me quote much more confidently by basically just saying, you know what, there's $40 in every setup for a new chunk of aluminum. And that way, like that template is dialed. I never have to change it. I always just do it this way. And, for most parts, $80 in setup fees of a part is, even if you're only making one, it doesn't kill the price.
Right. Helps your scrap pile too.
Yeah. Right. Yeah. Do you guys take your scrap for recycling and like get beer money from it?
Yeah. I think
Chips?
I actually need to do it today. I think I got 9 or 10 drums of aluminum waiting to get dropped off. And
That's a lot.
we'll do lunch or something like that.
Usually my stuff is so mixed that if it's chips, I just throw it right into my landlord's dumpster. Anything that's scrap steel, right into the dumpster. I'll save stainless steel, aluminum, but even depending on the stainless steel, like a lot of 400 series, I also work with 400 series, and that's highly magnetic. Use that a lot when it's like rotational shafts where it's near food contact, so they can use these really strong rare earth magnets to zip ties, and the materials, everything has to be highly magnetic so you can magnetize through your product and make sure there's just no like metal dust from wear or anything like that. So the scrap guy is always like, oh, see, the magnet sticks to this and you're not going to get anything. So like anything like that, typically I'll just throw right away. Augers, things like that, just get into the scrap bin. But if I know it's 316L, I'll usually try to separate it a little bit, but sometimes it's usually not even worth it unless it's like drops from the water jet or something like that. But usually just aluminum because it's pretty easy. You can keep it outside on a pallet, and then I'll just like scrap it when there's a few 100 pounds of it. But otherwise, it's not really worth the time.
Yeah, the only scrap I ever try to keep is like brass or copper. Anything else, I just get rid of it. And my landlord has like a metal recycling dumpster. It's a HVAC company, and they throw like old furnaces and stuff in there. And he's like, put whatever you want in there. Go ahead. So I just dump it in there. It's not worth me driving 20 minutes or half an hour to get $15 in scrap.
Our scrap place is right next to a place that has delicious apple cider. So I'll usually go get some donuts or some cider on my way home. Kind of just take the long way. It's kind of worth it then, but yeah, usually not.
Let's talk about expedite fees. I always tried to go after jobs that were short turnaround because I felt like they were much higher margin. Super stressful way for me to run a shop though, because I was always 2 days away from a delivery date, and just starting a job. Do you guys charge expedite fees? Do you take expedited jobs like that? How do you think about that?
Yeah, I mean, I'll take expedite work. We have a minimum lot fee. It's usually like between $1,000 to $1,200. Doesn't matter what it is. That's a starting price. And then within our standard lead time, like if you want it done in under a week, that's what you're going to pay on top of the part cost. And then if you start pushing that out, say you can wait 2 weeks, the price will go down and down to like our 20-day or 30-day lead time.
Interesting. So you'll decrease the price like kind of continuously on like a 1 week to 4 week schedule.
Yeah, we'll usually drop a couple $100 a week until we hit our standard like cost. Because a lot of our customers, they'll really want a part because their assembly line's down. Like, hey, we need 100 of these. We're willing to pay this $1,200 expedite, but maybe they can wait an extra week and they could save $400. So giving them options is always nice.
I was listening to the Precision, Impact. What is it called? Devin and Ariel's podcast. Why am I'm spacing on the name right now. They were talking about how like, thank you. Incremental is the podcast. Yeah. Like oftentimes your customer wants like 100 of them tomorrow, but it's because they ran out and they really need like 3 tomorrow. And so like, can I give you 3? And then I'll give you the other 100 over the next month so that you can go back to your minimum number. And like, that is a much more realistic scenario than give me 100 now. I thought that was a really interesting way to communicate with a customer. I never tried it. The closest I ever came was when whenever a customer asked for anodize, because again, we were always doing stuff short turnaround. So my anodizer had a minimum 5-day fee. And so my quote would always say, here's your price, including the anodize, but also this price includes, if you want, here's the cost for 1 extra part to be made and mailed to you in 2 days. So like a non-finished part, non-anodized part. Some of my customers liked that, and some were like, "No, we'll just wait for the anodize. It's fine. 1 week is a fine turnaround." But that always seemed like a good option to just include it on the quote, whether they asked for it or not. On the off chance that they like basically increase the order just to get that one part a little faster. Do you guys ever, when you submit a quote, like sometimes I would get a request for like 1 part, and then I would submit a RFQ and it would say, here's your price for 1, here's your price for 5, here's your price for 10. Do you include like quantity pricing in every quote you send out, no matter how much they ask for?
Typically not.
Customer.
Yeah.
No?
I mean, the customer will usually say, hey, can you quote me 1, 10, 20, 50? And then we'll do it. If they're like, hey, we only want 1, then I'll just quote for 1.
Yeah, typically I just quote per the quantity requested unless I know the customer and it's like a replacement part. Or if they specify like 1, 5, 10, what I'll do is when I'm quoting it, depending on how many pieces I can get out of a bar, I won't really, I'll price their quantity, but I'll also give them like, instead of 1, 5, 10, it might be 1, 12, and, 26 or something, depending on like margin of yield. And I'll include that stuff just because then I don't have to worry about having the scrap left over and I'm kind of making that into money.
Oh, interesting. So you actually show your customer like what the sort of natural batch size would be for them. Yeah. And you've had them take you up on that? Like, oh, sure, I'll take 12.
Almost every time they take it on from that way.
Wow. That's awesome. That's a really great way to communicate with a customer. I really, really like that. I never thought of that before.
Because like a cut charge for me from my supplier is going to be like not usually worth it, where I'm like, all right, I'll keep the drop, but instead, I'll just have them, sorted out that way, and I'll just transparent to the customer and kind of make it worth their while that way.
Okay, this one I think is a little controversial. I have talked to a couple of Toolpath customers and Instagram friends who sometimes they're like, all right, I'm like super busy right now, and like, I just really don't want to take a quote, or I don't want to take on any more jobs. I'm so backed up, but this is a great customer and I don't really want to no quote them either. So I've told them like, why don't you just triple your quote, right? Like that way, like you're less likely to get the job. And also if you do get it, at least you make 3 times the money. Have you ever just like straight up tripled a quote to like, please go away price?
Oh yeah. That's usually if the customer or the job is not within my scope of work or scope of wanting to tolerate it. But it's not necessarily like sometimes 3 times the price, like depending on the customer, sometimes double would make them shell shocked enough to not go through with it. But it depends on how much I want to keep the relationship. And sometimes I feel like it's better just to be honest and tell them that I either don't have the time or, tell them what my realistic time frame would be. And kind of go about it that way. If it's something where it's like a first time customer or someone's been a pain to try to collect money on, I'll price them out instead of just telling them no. I'll kind of make it their decision to not do business with me, but that's usually like the end of a relationship, I feel like.
You ever won a quote that you bid up unexpectedly? What do? You just do the job?
Depending on the customer. Otherwise, what I'll do is I kind of use like the one time I can think of, I won the fuck you price on it, and I just gave them a crazy lead time afterwards. I'm like, all right, well, it's going to be like 6 weeks, and they're like, oh, we need it sooner than that, and it's just like, well, that price is for 6 weeks, and kind of like just try to come up with something else so you don't have to, it depends on what's really written out in the quote, but.
Yeah. I think that's an important note. If you're going to send a go away price to somebody, make sure it's high enough that if they do accept it, that you can like stomach the pain. Yeah. I, along with that, sometimes wonder, like, people ask, what's your shop rate, or how do you quote? Or like, I've had, people tell me like, oh, a customer gave me a target price, or they gave me a Xometry price that they want me to compete against. How do you go about figuring out, like James or Jon, you said you're at like 70% success rate. Like, how do you find that level, right? 70% feels like a good number. If you're winning everything, you're not charging enough. If you're winning 10%, you're charging too much. 50 to 70% feels like kind of a good ballpark. Do you like actively play with your pricing to keep it in that window, or?
That's that handicap factor I was telling you about. I would kind of use that to my advantage. And once I realize that I'm not getting near that, and I'm probably at like 30 to 50%, then I realize that either, it could be, if I know it's a customer that I'm doing business with, or if I knew that it was kind of like a high handicap and I didn't get those, it gets to a point where, again, like if I have a lot of work going on, I'll kind of like use that sometimes, but I'll just bring that handicap back down a little bit. And once you can kind of see where like a job will start coming back in, and, you kind of find a sweet spot that you want to be at. Because I'm a one-man show, I used to like overwork myself and not charge enough, where I can not overwork myself and still make the same amount of money. So I kind of try to find that balance that I want to be in, and I kind of find that happy medium with that handicap to get into that spot where I want to be.
You ever done any experimenting, James? Just randomly tried raising your prices to see what happens?
Yes and no. Not necessarily directly with customers. I mean, I don't do all the quoting for our company. I only do all the CNC type work. Next door, we have played with that. Like, we've doubled or tripled prices just to see what would happen. And I mean, a lot of our customers are like tier 1 defense contractors, and they have money that I can't even fathom. So they don't even blink. And it's like, okay, well, that's your new price now. And I mean, we do get a lot of pushback on some things, and then that's when we'll reevaluate and like, okay, maybe we pushed too hard to try to get more out of this part. But yeah, for the most part, I don't try to do that. I try to be honest with my customers. It's like, if this is how long it's going to take and this is what's required, this is what it's going to cost. And I do get some pushback because some of my customers go and they get bits from other shops. And so they'll tell me, hey, well, we got quotes at like $1,500 a part, but you're $2,400. Can you work with us? And that's when I'll reevaluate and I'll say, well, if you make these changes, I can get close to that number that you want.
Would you ever roll a dice during a quote and add 10 times the dice number to a percentage?
Now I don't feel like I have to, so I don't really think about it. But I can kind of feel if my price is high, if it's low, like, and that's kind of what I go off of. And I'll I'll explain it if I have to do the customer. If I feel like I'm low, maybe I'll play with numbers. I'll change pricing around till a point to where I'm comfortable. And then if my customer has pushback, I explain why, or try to have a logical reason of why I came to that number.
What about you, John? Would you roll a dice and add a percentage to your quote?
No, because I can't really quantify that in the future. So that's why I kind of go off like my handicap. And it's more or less trying to, be transparent to the point where like, I know what I need to do or make to do certain jobs. And, against kind of James actually, like, or with James too, it's, some of my customers will say like, we've gotten a price for this much. And I know that sometimes depending on the work, like turning work, I can do pretty good pricing on or make pretty good money on a job. So I'm usually more willing, if I don't have to touch it as much, like if it's a bar pull job, things like that. But I take into account opportunity costs for other work that I'm doing. Like, if I'm not going to lower my price, to take on a machining job, if I can replace it with a welding or a line boring job, because at the end of the day, I'm hurting my business if I'm going to do that just to, kind of get another, invoice number out the door. Whereas I'm more focused on, I don't know if it's just making money or doing the right thing for the business sometimes, where I'll just make that decision. I was saying, it's like, it's not worth it for my business to do that job. And because I feel like there's some sweet spot where I am delivering value, or, some of the values I deliver rather, where it makes more sense to say no to a job and wait, because I don't need to add the value that I have. If they're just looking for a Xometry price, it's like, order that from Xometry then. Like, there's someone that's going to be way cheaper than me, and I don't need to compete with that. Whereas sometimes I'll have a particular customer, actually, he'll usually just show me the Xometry price. And more times than not, if it's turning, I'm like, oh, I'll do it for that. And it just seems like it's like easy money. So I kind of just, I don't know, I try to keep the ball in my court for what jobs I want to take on, because at the end of the day, if I'm the only person doing it, I can't, without having employees, that's kind of where I like the CNC work, because if I can not have a lot of time into a particular job, and sometimes like if it's longer cycle times or if it's a bar pull job, then I can get that set up and then go do other work. So it's just adding to my revenue. It's not really taking me away from revenue that's like more important, or higher profit, I should say.
Okay. We'll get to quoting some parts in a minute, but I have some more bad ideas to try out on you guys and see what you think.
I like peer pressure.
Would you ever put it on your website that you welcome customer provided price targets in an RFQ?
No, never.
No,
never. Like if I really like that customer, I'm willing to work with them. But if it's just someone I don't want to tolerate and I don't like dealing with, like they don't pay on time, they're always a nightmare to deal with, I would never. It's like, this is the price, and if you want it, cool. If you don't, then maybe we're just not a good fit. But some of the customers, my primary customers, I really like dealing with. So I'll deal with the engineers and the quality people. We work closely together. And if there's something where they got a quote and I'm significantly higher, they'll work with me and I'll work with them. And I'll let them know, like, hey, if you got a part from Xometry at X dollar and I'm X dollar higher, just let me know. And then I'll see if I can either match it or get close to it. And typically I win that bid anyways.
Would you put it on your website, John?
I don't think that it would hurt me in any way. Some of my industrial customers, they'll present a price to me just to see if they said, this is available. Is this something that you could even compete with, whether it's a replacement part or a repair part? And it kind of just gives me the freedom. And a lot of times I'll say, no, I might be a few $100s more. And they're like, well, we like working with you. We'll give you that. Or if it's like Pat from Practical Machinists, where he'll say like the walk-in Wednesdays kind of thing. If I have a local customer come in and they need me to save the day on something, I usually try and like stop the conversation as soon as possible and try and get a budget in mind, just so I don't have to waste 40 minutes of talking to them. And they're like, "Oh, I thought it was gonna be like $30." I'm like, what? So it depends on who it is, but sometimes I like to do it just to like kind of cut them off at the hip and show them where the door is, and I can go back to my job instead of, wasting a lot of time just to realize that like their perception on the cost of the job is nowhere near in the ballpark of what it's going to take me to do the job.
I've never dealt with a walk-in ever. That would be really interesting.
You get some good ones. Put a sign up out near your door. We welcome walk-in machining work. And see how that goes. Maybe have a diary with that or some journaling.
Oh man, it might be interesting here. So our shop is in like the back of a parking lot in an industrial place, but it's also surrounded by like 3 steel mills. So if I put a sign like machine shop walk-ins welcome, like I don't know what I would get. It might be kind of interesting.
Wow, you got to report back.
Make an Instagram page instead of people at Walmart, people at Toolpath.
Oh, my team would take way too good advantage of that and put pictures of me up all the time.
Oh, it'd be so good.
It'd be worth it for the people.
Yep.
Okay. You guys think we should quote some parts?
We could try.
All right.
Or
right? Yeah, or no quote. You can no quote them. No quoting not allowed on these parts. Okay, so
that
for
was
the
not in the rules.
Oh.
No, you got to quote them. All right. So for the listening audience, I'll describe the parts for you guys. For the viewing audience, I'll do a screen share and bring the parts up on screen, just so you guys can see what the parts look like. But here are the ground rules that I gave everybody for these. Just keeping in mind that both James and John are Toolpath customers, so they can both use Toolpath if they want. But I gave them 2 parts. One of them is a steel part. The other one's an aluminum part. And just to keep everything apples to apples, I gave them a shop rate of $150 an hour. So you guys are welcome to quote the parts however you want. But if you want to quote hourly for shop rate, use $150 an hour. And then if you want to charge for setups or something, stick with that $150 an hour rate if you want to bill by time, or put a flat fee of $100 a setup in if that's how you want to do that. I'll give you stock cost for each part, and I'll go through that as we go through the parts. I just pulled the stock costs off McMaster because, surprise, all these customers want their parts tomorrow. So you're probably buying from McMaster. I did set you guys up with a tool library pre-prepared in Toolpath into each of your accounts. It uses the new tool recommendation engine. So for this context, the tools you have in your shop are the ones that I put in your library, and anything that's recommended by Toolpath are ones you have to buy. If you don't want to use Toolpath to quote the part, then it's up to you to know whether you have the tools or not. I think those are the rules. Did I miss anything, guys?
No.
The one thing I would just say, as far as when you said it's the McMaster, actually an old boss of mine, he used to tell me that, like, when I'm quoting a job, just to always kind of assume that, especially if it's a 1-off or 2-off part, just to quote it from McMaster, because worse, at the end of the day, you can still get it the next day or 2 days, and you're not going to lose money on the part, like on the material. So I thought that was always a good tip.
Okay, I'm going to share my screen. I'm going to get the little infinity thing for a minute. So here we go. This is part 1 here. So this is a pretty decent size 4140 plate part. Customer wants it tomorrow, if they can have it tomorrow. The part, and I'm just going to describe it so that if you're listening to the podcast, you have some sense of what we're looking at here. But hopefully, if you're watching on YouTube, you get to see what the part actually looks like here. So the part is 12.01 inches in X for op1. And it's, let's see, what is the actual part size here? It's 1/2 inch thick, and it's 8.26 inches in Y. And just so the people on the internet don't think that I was making up a part to be intentionally difficult, this was legitimately the size of a part that I was asked to make. 12.01 inches in X. It was maddening. So this is 4140. It's a pretty good sized part. The material removal, you're taking away about half the overall material. It's kind of mostly just like one big profile of a part, half an inch thick. There's 1-2 holes in the part besides the profile, and one kind of challenging filleted, not filleted, chamfered, like a really large chamfered feature. And of course, at the bottom of that chamfered feature, the customer has left a sharp corner to be machined. So, John, we'll start with you. Oh, I have to provide you with the stock cost. So because this is a 12.01 in X part, you have to decide how you want to order parts for order stock from McMaster. They do offer a 10-inch by 12-inch 4140 plate. You could buy it at half an inch thick if you're willing to gamble on like material warpness, material thickness and everything. The customer is okay with a mill finish, but they have spec'd like that the part needs to be flat. They didn't give a tolerance though. We're not doing any GD&T in this game show here. So that costs $116 per plate from McMaster. You could go a little thicker if you want to buy a 5/8 thick part. That goes up to $130. Or if you want to make sure you have enough material to make the part, like 100%. These are oversized sheets from McMaster, so they're promised to be 1/8 of an inch oversize. If you want to make sure you have definitely 100% have enough like extra material to make the part, you could order a 12-inch by 12-inch plate. I guess that doesn't really actually give you any more room on your critical dimension, but you could rotate the part a little bit on the diagonal to make sure it fits in there. And those parts go up to about 150, like a 12-inch by 12-inch plate goes up to about $150 up for the stock. Overall material removal, Toolpath doesn't actually give me that number because like total material removal volume isn't important, but I'd say you're removing about, out of a 10 by 12, you're removing about half the material. All right, John, we'll start it with you. Do you want to quote this part? Well, what do you want to quote this part at?
So
walk us through how you think about it.
For the intent of the podcast, I will quote it. For the first time I saw this part, I thought that you designed this just to make me cringe. I would no quote this part just because I don't have any interest in it, and it looks like it would be kind of difficult on where that internal corner of that chamfer to the there's an outside radial corner, and it gets kind of thin there, and I feel like
right here.
Yeah. So I feel like I would have to flip it a couple times to keep it pretty flat. So if I were going to do this, especially with a 3-day turnaround, I would probably have it around $1,650.
Okay. Because you commented on this sharp corner, although you didn't do it right now, but also on this thin area, I'll tell you that I actually don't care about this sharp corner, or the customer doesn't care about it. And they're willing to throw like a 1/4 inch radius on that entire part of the part. Does that change your mind at all?
No, just the way that, I mean, I would end up surfacing that, I guess, if, or using just a sharp point chamfer mill to do that angle, because it was 45 degrees, I believe. I actually didn't measure that part. I only looked at the part that I thought was cool, that aluminum part, and that has that inside was 45. So
let's see. Is it a 45 degree angle? It is not a 45 degree angle. Toolpath is telling me it is a 47 degree angle.
Yeah, so that would have to get surfaced then.
Right. I'm trying hard not to make this a commercial for Toolpath, but this angle did screw me over when I quoted the part. I thought, screw me over. I thought I could just hit it with a 45 degree chamfer mill. I had a decent sized one. I was like, oh, this won't take that much time. And then because of that sharp corner there, I ended up having to surface the whole thing with like a pretty small ball mill I think they allowed me to have like a 1/16 inch radius or something. Well, What about you, James? How would you quote this part?
I would run it through Toolpath and see what it does. I mean, I haven't looked at this part except for 2 minutes ago, so I was trying to make this as authentic as possible.
Okay.
I don't even know. I don't have a definitive price. I would obviously surface those, and if you can add a radius on the inside, I would have to try to get it to do what I want it to do. But I'm running into an interesting situation with Toolpath, it wanting me to use 4 setups.
Oh, okay. Yeah, this is a challenge with Toolpath right now. It's something we're working on, but it wants 4 setups because of those stupid sharp corners. So it's adding these setups to it here just so that it can like.
If you couldn't surface that, I would actually put a vise on an angle inside a vise so I can actually machine those with a sharp corner to be able to get those correct. And then it doesn't really matter what the angle is, but then you still have to face both sides afterwards for the flatness.
Well, but you'd struggle to fit this part in a vise and have enough Z to get in there. Yeah. I mean, let's talk about work holding for a second. Yeah. So this is an interesting point where this is a 2-op part, but Toolpath is saying it's a 4-op part. And that's an area where we really need to, we're actively working on it, but we need to improve Toolpath. This is the AI being in try hard mode. So it's like trying really hard to machine everything it can as modeled. And there's this really challenging problem in the industry where like as modeled is not the same as manufactured.
When I'm talking about that though, I don't necessarily mean I'm going to do my CNC. I would finish that up in my manual mill.
In your manual mill. Yeah.
Because I have a riser on the headstock, so I have a lot of Z on that.
Oh, that's true. You know, since I don't have like an old knee mill or anything, I don't think about that. But yeah, they have way more clearance on those parts.
I have a 40 taper boxway manual mill with an 8-inch riser on that turret, so I could do that with no issue really as far as those angles.
Wow. Okay. What about work holding? How would you hold this part? It's kind of shaped almost like a question mark.
Yeah, it looks like if you were to take a revolver and stamp it out, it would kind of look like that profile is the best way I could describe it to people that are just listening. So the way that I would do it is, so it's kind of like if there's a U cut out of, let's call it the center for argument's sake, I would machine through a flat respective parallel to each of those profiles first, so I can machine those angles, and then I would put that into the mill on probably a fixture in the CNC afterwards and do the rest of the parts that way. So I would do that difficult part first.
Yeah, I would do the opposite. So I would face the flat side first and then flip it over and use Dylan Jackson's favorite thing of powder coating tape and super glue. If it's only for one part. If we're talking more parts, I have a Pearson vacuum plate that I'll make a custom top plate for, and I could just pop it on and off.
I tape and glued this part when I made it for sure. I think this was the first part I ever tape and glued actually.
I've not tape and glued yet.
Ooh, you don't know what you're missing. You need to give it a shot. Yeah.
Yeah. Go watch John Saunders' video on it.
Yeah. When I visited Dylan's shop, his business partner, Brad, showed me some of his secrets for tape and glue. And just a hot tip, one of them is to burnish the tape. John Saunders talked about burnishing the tape on his video too. But Brad had showed me how he like uses his fingernail to burnish the tape really effectively. And that just seemed insane to me. So up on our website, on the Toolpath website, I made a burnishing tool, like a little burnishing handle. You put we actually did some like experiments, and we found that a 1/4-inch dowel pin was like the right size to give you enough pressure to effectively burnish. So there's a 3D printable burnishing handle up on our website called the Brad burnishing handle. So anybody who's listening, go get that, make yourself a burnishing handle, and improve your tape and glue considerably. But yeah, like he can cut the color off the tape because he's gotten so precise about how he lays it and everything.
That's impressive.
The challenge with this part on tape and glue for me was actually getting it off the glue. Well, it's just like you don't want to have to like stick something in there and pry under it, and then there's like a really thin area on the part here, so you can bend it.
Doesn't
but it's
EPA or acetone release that or not?
Acetone will, yeah. But if you've done like a really, really good job at gluing it, then the acetone takes forever to wick into that setup and like dissolve the glue. Which is why sometimes you see people will put like gridding underneath their glue fixture, but the tape kind of counteracts that. So just bear in mind there are ways to get it to release. Certainly, you could dump it in a thing of acetone. Although a part this big, you'd need a pretty big container of acetone. But you can also use a little bit of heat to get it off as well. And then sometimes you can even put like a pocket under the fixture to have something to pry on. To get the part up.
Yeah, that's typically what I'll do.
Yeah. But this would be just from the size alone, this would be an excellent vacuum part. Like 100% would do for sure. And even with, even on a one-off for this part, I might still do it with vacuum because Jay has that nice plate where you can put the gasket in and stuff, the Pearson vacuum. So even there, I don't know that would take you much more time than setting up tape and glue.
I would figure vacuum just because I would do a pass and see which side it was concave or convex, just so I can kind of inch up on that dimension on it. And I've never worked with tape and glue, just so I wouldn't know where to start with that. As far as if I did get it off and it was final size and I had a bone and I'd like try to manually straighten it or something.
Next time you visit HGR, stop by the Toolpath shop and we'll make a tape and glue part together.
All right, right on.
I'm certainly not an expert on it, but I've done it a few times. It's not so scary once you get the hang of it. And it works great for parts that vacuum won't work on.
And this powder coating tape that he uses, or you guys use?
Mm-hmm.
Yeah.
I use that for back purging on welding and stuff like that because it handles the heat pretty well.
I still don't completely understand why we tape. It seems like metal on metal would work fine. I mean, I do tape because everybody says to tape, but it also just seems like facing a nice piece of metal and then gluing it right to that would work as well. So
maybe the tape's more porous. I don't know.
Yeah, I don't know. I don't have a good answer for like why we use tape.
Need to ask Brad.
On plastic parts, it makes a lot of sense because you can't always dip those in acetone. And so the tape protects you from having like a super glue finish. But
that's fair.
Yeah. Okay. So you quoted this at 1,600, John. That's for one part. What if I wanted 15 parts and I was willing to make some adjustments so you don't have to do weird manual machining tricks on this?
Well, if I was going to do multiples, it would be easier to do it than manually, I feel like, because it would be set up for each operation. But
interesting.
On something like this, I don't really know if I would drop the price much. Maybe besides if it was going to be a standardized angle, or I would see how much a form tool was at that point. Like Dave at Carbide Cutting Tools, just have him make me a tool that will work for that. And then if the lead time allowed, it would be a little bit easier just to kind of buzz along. I also have, it's too large of a radius, but I have an adjustable chamfer tool. So you can actually like change the chamfer, but you'd still have to like surface the inside corner depending on the radii dimension or like tolerance on it.
How does an adjustable chamfer tool work?
It's got a TPG insert that you can actually like loosen a screw and you can actually change the angle of your chamfer.
Oh, you just blew my mind a little bit.
I'm a whore for tools. So.
All right, James, give me a price. I have to have one. I need it in 3 days and you're my shop. Give me a price. You can't say no.
I don't know. It's one like this that Toolpath doesn't spit out, because I haven't done manual coding since August, September. I've just relied on Toolpath so heavily since then. I would say between 17 to 2,000.
Okay. All right.
Factors. I mean, I would obviously surface all those angles. I could either use tape and glue and not charge a prep fee for the fixturing, so I could drop the price down a little bit. Like I have options of that, and then figuring out and it depends on the customer. It depends on the lead time, and there's a few little factors that play into that. I mean, typically I would just no quote this because I don't do much like standard steels, to be honest. So I don't know how far I could push certain tools, things of that nature. And then I got to clean my machines out and stuff like that. But yeah, I would
41, sorry.
No, go ahead.
I was going to say you never designated the hardness of the 4140 either. So I would have just assumed
that is the sign that you are not as novice a quoter as you say you are right there. Because honestly, I wouldn't have even thought of that. But I machined this out of a annealed 4140. Typically, that's like, unless otherwise specified, why would you order anything but annealed? But you're 100% right? I think you can harden 4140 to like 50 Rockwell or something, right?
Yeah, 52 or something like that, I think.
Yeah, that if you had to hard mill this, that's that's a lot of material removal. You'd almost certainly.
I would actually think that it would be easier to do a pre-hard than anneal just because it's less gummy and you can kind of get a better finish that way. But it also depends on that flatness as well, because then you're going to have the stresses in the material to worry about. That's what I was saying on the vacuum fixture.
James, I know how I could get you to quote this part for me.
Okay.
What if I told you that it was a bracket for my racing Miata and I needed it tomorrow to compete in my spec Miata league?
10 grand.
Because he said,
I don't know. Yep. This bracket's going to cost more than the car.
Just for you guys' perspective, you may be interested to know that I made this part for $400 the first time I made it. And that's what Xometry paid me.
Yeah. No.
And then the second time they sent me the job, I made it for $800. But
that's surprising because usually when I get recurring Xometry jobs or repeat jobs, they bump the price down. And then I'm like,
but then I always counter it back up. Yeah.
Yeah, and that's what I do. Like there's a few jobs, and I don't do a lot of Xometry work, but there's a few jobs that I'm like the only person that's ever made them, and they try to bump me down on price. And I'm like, no, like I was okay with the last time I did it. Let's just stick with that price, and they don't complain about it.
I haven't done Xometry work in over a year now, so I don't know what the current meta is on how to game their pricing engine. But I would always raise my price the second time around. I just like they would almost always accept it. So
I haven't done any Xometry work.
From what I hear these days, you're probably better off.
That's what it seems like, from what I understand.
I wasn't going to say anything.
Or have a lot of remnants and time, and
yeah, once you get into like the premium or ultra premium, like for me it's worth it because I have ISO, AS, ITAR. Like I talk regularly or somewhat regularly with the people that deal with the higher tier customers, and they'll be like, hey, what do you think about this? And there's a lot of going back and forth to where it's not like your typical job board of, hey, this is the price, either take it or don't.
Brad at Marvel Machining seems to do very well in the tier that he's in with Xometry. It's like it's like carte blanche for making money, it seems. But he's also ITAR as well, and he has a really, really good at CamWorks, it seems.
There seems to be a few people who've cracked the code. They tend to be the ones who have had Xometry sort of from earlier days or whatever, and they can make good money on it. But it's definitely a rough go starting out to like get enough business with them to have them give you good jobs. So you kind of got to be willing to slog it out. Yeah.
Yeah. Like I couldn't imagine being that guy with like a Tormach or a mini mill in my garage, and I don't have ITAR or AS or anything that would get me in those higher brackets. Because I see some of the regular work.
Tormach, and he seems to do pretty good on Xometry though.
Yeah.
Who does?
Just from what I see.
Audacity Micro.
he hasn't had a Tormach for a while, but wasn't one of his most recent episodes talking about how he's done with Xometry?
I thought he just got a newer Tormach, didn't he?
Oh, he did. He did. You're right. He did get a 1500 MX. Yeah. He had an older Tormach before that. He traded that out for a Haas office mill, but he did get a newer Tormach. Yeah, the 1500. That's a neat machine. I'd like to play with that machine some for sure.
I'm curious to see what Jon has to say about that.
Yeah,
since he got his.
Yeah, he talked a little bit about it on his podcast. Seems happy with it so far. But hopefully he'll put some content out on it soon.
Yeah.
Okay, so interestingly, you guys both came in at about 4 times the price I originally made making this part. So good for you. Hopefully somebody will pay you that much for it. Jon won the bid at $1,600 over $2,000 for James this time. Let's take a look at the next part here. This part is a part for an aerospace company. They are a little price sensitive. Just FYI, they're a customer that does tend to be a little bit price sensitive. They're not super particular on GD&T, and just, you've figured out through working with them that they actually don't have any way to measure the parts themselves when they get them. So as long as they bolt together okay, then they seem to be all right with them, no matter what the print says.
And they're aerospace?
Happens more often than you'd think. There's a lot of small aerospace companies out there, yeah.
I deal with one of them. They have a QC department, but they don't have really any QC measuring, like no metrology equipment.
Yeah. So sometimes I would like to say, I don't know if you guys ever watched the show, Whose Line Is It Anyway? But I would say this is a print where everything's made up and the measurements don't, and the dimensions don't matter.
And it's
so,
aluminum?
And it's aluminum. Yep. 6061. Yep. Yeah. So for our listening audience, this is a round part. It is, how big is it? It is
5.182 in diameter.
Yeah, 5.182 in diameter. Thank you. And it's about an inch thick overall.
Yeah, 3.
Yeah, Toolpath is suggesting 5 1/4 by 1.25 inch thick stock. The extra thickness there because Toolpath is always assuming you need grip stock. The customer wants 1 week turnaround on this, so 1 business week, and they want 4 parts. The stock cost for McMaster is somewhere between $50 and $60 a part, depending on whether you ordered square stock or round stock. And then I should say, again, so it's a round kind of disc part. There's a wall on both sides, kind of like a thin wall. And then along the sort of circumference of the part, there are 8 cross holes in this part. And then on one side of the part, there's like a bunch of open pockets that have like fillets on the top and bottom, of like floor fillets and top fillets on the top. Okay, James, we'll start with you on this one.
I counted only
Alrighty.
6 of the cross holes. You have 8?
Oh, you're right. 6. There's 8 setups. I'm sorry. Because of top and bottom, there is only 6 cross holes.
All right. I just wanted to make sure I thought.
Is there any outside processing?
No outside processing.
Okay, I'm looking at 1762.39.
All right, you have that number there. And I'm guessing you'd use the Toolpath machining estimate for that?
Yep.
What did you get for that one?
1762 and 39 cents.
Okay. All right,
Yours is
1700.
actually slower than mine.
Yeah, I'm not sure on my thing if I have the exact same thing that I set up for you guys. The pictures are coming off my development account because I wasn't smart enough to sync up my account with yours. So $1,700 for all 4 parts, right? That's the part. That's not the per part cost.
Actually, I only quoted 1.
Okay. What's the price for all 4?
Something changed. So yeah, I'm 1634.07 for 4 parts. I realized I didn't have a few settings set up. So
so if I buy 4, it's actually $100 cheaper than just buying one.
Well, I realized my machining rate was set for $60 for some reason rather than $150.
Got it. Okay. That's a pretty reasonable price, I think. Let's see what John wants to quote it at.
Just by not using Toolpath and looking at it, I would have quoted it between $450 and $550 for each part.
Okay. Just shooting from the hip there.
Just looking at it, they would be 3 ops for me. And I would just do, like I was saying to you before, that I would use my super spacer just to use those holes, and I already have a hex plate in it, so it would be not too bad to just pop those holes into it. Those are 2.5 millimeter diameter on the outside.
And you have a 4th axis on your mill, right, James?
Yeah. So I would 0 point it, run it vertically, plop it on the rotary, the HRT, spin it around, do those holes, and then pull the part off to do a 3rd op.
Yeah, I didn't have a 4th axis or a super spacer or any kind of fancy work holding when I made this part. So we actually ended up doing it in 4 ops. Well, it depends on how you measure the number of ops, but we did the top and the bottom of the part. But then we basically milled a hex pattern into the center bore here. There's like a big center bore center hole that comes through the part. So we put a hex onto that lined up with the holes. And then we made some soft jaws with a shelf to set the height right. And then we milled the top and bottom, leaving the hex in there. And then we put it on its side and I guess did 6 additional ops, right? Rotate the part, drill, rotate the part, drill. The part is tall enough that fixture didn't hold it perfectly parallel. We didn't machine it carefully enough. And so we ended up having to like probe in each hole to get it in the right place. And then we took it off, put it back in the soft jaws from op 2 and milled out the hex and put the center bore in. That was a nightmare of a part for us to machine.
Put the hex in it, I thought you actually meant that you machined a hex into the like the outside profile. So then you would just put it between soft jaws, and then like I figured that you'd run like taller soft jaws just to kind of hold it a little bit more rigid. I didn't realize you meant by the center of it you were holding it.
Your way would have been way smarter.
I struggled a lot with parts, so that's why I'm like, I would probably try that, but
I don't know why we didn't do it that way. I don't know why we decided that this like central hex, like giant Allen key, was the right way to do it. But we did. We did scrap the first part because these holes didn't end up in the right place. So we had 1 setup part, and then we had to make 4 more. A couple of interesting notes here. There is quite a lot of machining time in these little fillets, unless you happen to have the right end mill for it, which we didn't.
1 millimeter corner radii.
Yeah. So that was not fun. And I actually asked them whether they cared about those, and they said yes. And the part actually had this mixture of fillets and square pockets. So I don't know what they needed some of them to be filleted for, but it was an interesting side note on that part for me.
Is an interesting part. Could just be like a stress analysis or something like that.
I have had one time where a customer asked me to machine a part and they said they didn't care what it looked like. They were like, machine it as rough as you can, make it as cheap as you can. This is a brazing test piece for us. I thought that was interesting.
Yeah.
Okay, so you both came in about the same area, but James won the bid on this one at $1,600 over $2,000. But I think it's interesting that you both are kind of in the same ballpark for this part.
So I got the job I didn't want, and he got the job I wanted.
That's right.
Yeah, I'll take this job.
You're stuck machining some 4140 now.
Oh, right.
Hey, I'm okay with that.
I might have
that'll teach you, man. You should have added a go away price and charged me like $4,000 or something for the part you didn't want.
Sometimes it's worth the learning curve, depending.
I will ask one more curveball. No, man, I lost my train of thought. I just had a funny idea. I can't remember it now, though. Wow. Okay. Hopefully we'll edit that out. But probably not.
To say some sort of outside processing or part marking or something like that.
No, I mean, the outside processing stuff, I don't know. That was always very difficult for me to deal with because when you're making one of something, you just run minimum lot fees for everything, which is fine. And I would always just try to let the customer know, like, hey, just so you know, this is how much you're paying for the outside processing. So if you want to come back to me and tell me you don't want it on this part, that's up to you. It was the scheduling that always drove me nuts.
I always do finishing as like a separate line item. Just to see it. Same with fiber, like marking and stuff like that too.
Yeah, I've never had to do laser marking on a part, so I don't really know how I would factor that in. It seems like it wouldn't be that much work, and now I'm questioning whether that's the case or not.
I actually bought my fiber laser for a customer that I make these brackets for, and so it was interesting because they're powder coated, and the time it would take to actual laser engrave and burn through the powder coat. And I also like kind of shy them away from it because of the cycle time for that. And that also there would be no corrosion protection, and it's an aluminum part and it's just like for outside. So I priced it in their favor to just kind of like, you know how like an undercover cop car, it'll just be like kind of a shadow on a black or something like that, or like gray on a white car. So I actually mark the powder coat so it's just like a little bit, you can see it, but it's not just it's not as bland as like a white powder coat, a white fiber marking on black wrinkle finish. And it's a lot easier that way because of how thick wrinkle finish is. You have to like really make sure you burn through it. Whereas I only burn through it just enough. And the problem with that is though that I do 600 or 1200 parts at a time. So there's just a lot of handling. So I want to make like a rotary table for my fiber so I can like load up 8 of them or something like that and just spin it around like lazy Susan.
More automation in your life is what you're saying.
Yeah, I love it.
Well, speaking of automation, why don't we close with that? I'll let you guys have the last word, but have you given any thought to automation and how you'll adopt it and pull it into your quoting? We'll start with you, James. How do you think you'll adjust your quoting once you have more automation?
I don't think I'll change it at all, to be honest. The only thing automation will help me with is turnaround times. Like I'm working on some prototypes now, and I found out last night they're going to go from 5 assemblies to 500 when these go into production. And for me, I'm going to save a ton of time with automation. But the pricing isn't really going to change. I mean, it's if I'm at the machine or I'm at a computer, the cost to run the machine's not going to change. I'm just going to get it faster.
Jon, you have the cheapest and most effective automation I think that's out there right now, which is a subspindle lathe, right? Yeah.
Oh no, I was going to say the Okumo bar pulling.
Oh, bar pulling, true. Yeah.
Yeah, that was really cool. But yeah, no, lathes are definitely the cheapest way to automate. And it's pretty cool, even just loading a 42-inch bar into the spindle and being able to turn the lights off and go home. It's really cool. Also, I agree with James though. I would not lower my price. I feel like I try and price the job. And if I'm there and the machine's running and I'm doing something else, or I'm home and the machine is running, I feel like if I'm getting the job, I'm not going to try and lower it for any reason, especially if I start getting into, palletized CNC or 0-point system, stuff like that. There's a lot of upfront costs with that. And I think that the value of having the automation is to be able to recoup that cost when you're not there. So I feel like it would still be the same price. It would just be more of an internal benefit at that point. And if you can have a reliable process, you can kind of slow things down a little bit. And, so it's not really actually machining faster. You might be machining a little slower from what I understand. But at the end of the day, if you have, you kind of have to go slow to go fast. So if you have less scrap parts and things like that, you're a higher efficiency, and I don't think you should burden yourself with a lower price because of that.
All right. So that's really cool. Both of you guys view automation more as like a force multiplier. It lets you do more quantity at the same price. But it's not going to force you to lower your price or to raise it for that matter.
I'd rather have automation than an employee. And at the end of the day, that's my outlook on automation. It's going to be more reliable than someone that wants to be on their phone or whatever else. And
James, do you think Jon should... No lunch breaks, yeah. No sleep, no lunch breaks. James, do you think Jon should invest in 0 Point?
Absolutely, 100%. And to be honest, it's always been on my radar, and it's something that I've always wanted to get into, but I didn't pull the trigger until Tim Paul shipped me 5th Axis 0 Points, and it's like, okay, now we're going to do this. And since he helped me out with that, you helped me out with programming and getting all like a fusion and stuff set up for 0 Point. It's an absolute game changer. Like every machine I have now will have standardized 0 Points and fixturing and things like that. And being able to jump from one machine to the other, especially if all my machines have the same control. I can move programs, I can move fixtures, I can move anything from one machine to the other, and it can make scheduling significantly easier and setups faster. So it's a decent upfront cost, especially for small, but it's paid for itself in the last month, I think, that I've been using it. Maybe a month and a half.
Interesting.
Yeah, it's worth doing, like 100%. And I'm still doing it fairly budget oriented. Like I'm using Haas 5-inch self-centering vices and then the 5th Axis base plates.
There's so many good options out there now too. Obviously you can go with like 5th Axis or Lang. We have HWR in our shop. Jamie from JSpec has his new anchor point out. Saunders has the puck chuck out. There's the Vero S stuff, so that you can kind of go like very, very low cost to very, very high cost. Even like just a fixture plate from Saunders is like a really good.
That's what I have on my Herco. I love that thing.
Yeah.
So it was a night and day difference for me. Like as soon as I bought it, I'm like, okay, this was the best $1,700 I think I've ever spent. And then I bought 0 Point stuff. And I'm like, well, this is even better. But now that I have them both, it's like, it's crazy. Because before, like having to straighten vices and doing all this other stuff, I'm spending so much time on setups. Where now I have my fixture plate set up. So if I need to put my rotary on, 3 minutes. If my rotary is already on and I need to go from a self-centering vise to a rotovice or to a 3-jaw chuck, it's 30 seconds. My programming doesn't change. My work coordinate system doesn't change. None of that stuff changes. And I can go from a 0 Point setup to the Saunders mod vices. Sorry, there was a struggle for that one. But I can go to mod vices, then I can go to a 6-inch like Kurt vice, or I can go to whatever fixturing, and it's only a matter of a few minutes, if that.
That's impressive. I have the fixture plate from Saunders, the 4141, but it's more so just because like the first time I was doing some stainless steel flanges, they were like much larger than the 3 T slots in my Herco. I'm like, oh, so like you're fighting like material, like warpage and bowing from that, and after that job, I'm like, I just need to be able to hold down my work anywhere, but I don't even have, like, my vices are just bolted down. They're not pinned in. And so I'm using it in the most archaic fashion, but it's still like leaps and bounds nice because anywhere I want to put a material stop or support, it's just right there and able to. But typically I'm running 3 6-inch vice, but I run, because of that part that I do 600 or 1200 at a time, it's a 3-inch by 3. It's aluminum flat bar. So I do everything in a single op. So I'm like back chamfering and everything, even in the holes, or I'm running a, I forget the name of it right now. The Cogsdale Burrowway through the 3/16 holes. So it'll backside chamfer the inside of it like a high-speed steel drill. You just go in through and spring loaded. Just so when they come off, they're one and done. But I run, since those are 11 3/4 inches long, I run 9-inch wide, 2.5-inch tall by 2.5-inch aluminum soft jaws, just so I can get full support on material for each vise. And so like a lot of the parts I do are like different sizes. So like, that's what I was saying. I'm able to get like several jobs out of one set of soft jaws just because of the size soft jaws that I run. But I kind of just take advantage that way. I try and just like save minutes where I can.
Yeah, and that's the name of the game, especially with smaller shops. Like, I only have one good mill, so I gotta take account for every minute that spindle's not turning. And yeah, going with the Saunders route, doing a lot of Pearson stuff, and then going 0 point, I can have fast turnarounds.
That's cool.
All right, guys. Well, listen, thank you so much for hanging out with me for 2 hours. I certainly learned a bit about how I was quoting wrong. So I appreciate your guys' insights. I don't think you guys are as novice at quoting as you think you are.
No idea what
Thanks for having me on. I feel like I still don't know that much, though, compared to everyone else out there on Instagram and all of that, though.
Well, I think there's a lot more folks out there like us who feel like we don't know what we're doing with quoting than the ones who are like very, very dialed in and feel like they're very confident about their quoting.
But someone can help or benefit from our podcast, at least.
Well, before we finish up, why don't we just give you guys each a chance to let everybody know where they can find you on Instagram if they want to reach out?
I'll let Jon go first. I've been going first this whole time.
Thank you. So Jon at The Shop Incorporated on Instagram, pretty much on there way too much. So yeah, that's pretty much it though. It's just Instagram.
Yeah, I'm not very active. I should be. But yeah, you can find me at JE_adaptive. Or if you're into racing, my personal Instagram is Tis the Jameson. I don't really post much on either. I'm not. I'll watch stuff and I'll see what people have going on, but I can't post the majority of the work that I do, and that's all the fun stuff.
But if anybody wants parts for their race Miata, they know that you'll charge them 5 times as much for them.
Oh yeah, I'll throw it on Xometry. I'll get a quote and then 3x that.
All right. Thanks so much, guys. I really appreciate it.